Good day, everyone. Welcome back. This is lesson 2 of Unit 4 in Math 10C. We're going to be looking today at combining the exponent laws, but really what this boils down to is today in this lesson we're just going to be practicing applying the exponent laws that we've already learned about to more complicated situations. So today is about getting even more practice than you have been getting over the past couple of days. This lesson can be found on page 10 of your Unit 4 handout. And before we get going here, I would like to review the exponent laws. So to begin with, yesterday we reviewed, and these are basically all from grade 9 math, we reviewed this law which says if you have two powers multiplied by each other and the bases are the same, then you can express it as a single power where you add the exponents together. And this happens to be called the product law. It's for the product of powers. We also learned that if you're dividing powers and the bases are the same, then you can express the division or the quotient of the two powers as a single power where the exponent is the numerator exponent minus the denominator exponent. And we call that the quotient law. We also learned that if you have a product, in this case the product is xy, and it's being raised to an exponent, in this case the exponent is n, that power of xy, quantity to the n, can be written as x to the n multiplied by y to the n. In other words, when you have a product raised to an exponent, that exponent can be applied to all of the factors of the product, and we call that the power of a product law. When we have a power of a quotient, which means we have a base that's a quotient raised to an exponent. In this case, we have x over y, quantity to the n. We can write that as x to the n over y to the n. In other words, when you are dividing things and then raising that whole fraction or quotient to an exponent, you can apply that exponent to the top of the fraction, to the numerator of the fraction, and to the denominator of the fraction, which is on the bottom. And that is called the power of a quotient. This law says when you have a power that is raised to an additional exponent, in this case we have a power of x to the exponent of m, and that is raised to an exponent of n, giving us a whole power of x to the m raised to the exponent of n, we multiply the exponents together, and that is called a power of a power law. Lastly, we have the zero exponent law, which says that x to the 0 is equal to 1. Now, I want to make something clear to you. In moving forward, you're going to be applying laws and rules in mathematics in many different areas in the remainder of this course, and in your 20 level course, and in your 30 level course. And you have to be adaptable. So for example, when you look at the top of the screen here and you see what I've written for the product law, there's absolutely no reason why we couldn't say this instead. We could say that a to the m multiplied by a to the n is equal to a to the m plus n. The letters that are the bases don't matter as long as the bases are the same. So when you look at the left, we have a power with a base of x times a power with a base of x. So if the bases are the same, we can add the exponents. On the right, the two powers have bases of a, so the bases are the same, you can add the exponents. We could do the same thing for the quotient law. We could do the same thing for a power of a product law. I could say a times b, quantity to the n, is equal to a to the exponent n times b to the exponent n. We could do the same with the quotient law. Instead of having x to the m to the n, I could have, for the power of a power law, a to the m, quantity to the n. And the zero exponent law can be written as a to the 0 equals 1. So those are all of the exponent laws, and it doesn't matter what letters we use as long as the rule is consistent. In other words, for example, in the product and quotient laws, the bases are the same. I want to add something now that I felt I didn't want to address yesterday because yesterday in the previous lesson it was enough. And it has to do, first of all, with this law, the power of a quotient law. And if you look at the left-hand side of the screen, I'm saying x over y, quantity to the n, equals x over n, equals x to the n over y to the n. So the quotient x over y, quantity to the n, can be simplified by writing x to the exponent of n over y to the exponent of n. But there's a wrinkle to this, and it's that y is not allowed to be 0. And the basic reason why y is not allowed to be 0 is if the denominator is 0 raised to an exponent, which it would be if y was 0, then the denominator will be 0. 0 squared is 0. 0 to the 10 is 0. So if y equals 0, the denominator of this fraction is 0, and that means you are dividing by 0, and division by 0 is not defined. You cannot divide by 0. If you look on the right-hand side of the screen, that means I could say b is not equal to 0. I wouldn't lose too much sleep over the fact that the denominator cannot be equal to 0. It's just part of the rule, and when you get into 20-level math and 30-level math, we will be talking a lot about denominators never being allowed to be 0. It becomes an important idea. There's something else I want to address briefly, which has to do with the 0 exponent law. Very often I will say anything to the 0 is 1. And that's not technically true, because the base in this law cannot be 0. What I am telling you is 0 to the 0 makes no sense. If the base of that x to the 0, which is x, is also 0, then you have 0 to the 0, and that is not defined. Similarly, if you go on the right-hand side, a cannot be equal to 0. So this is a nice summary of all of the exponent laws that we've learned so far. Let's get to the lesson today. So going back to page 10, what we're going to be doing today is continuing to use the exponent laws to simplify exponential expressions and to learn on the path that we're following here some shortcuts. So question 1a says simplify 4x raised to the exponent of 7 multiplied by 3 times x raised to the exponent of 5. You certainly don't need to rewrite this the way I am going to. But I'm going to point out to you that what 4x to the 7 is 4 multiplied by x to the 7. And we're multiplying that by 3x to the 5. And 3x to the 5 means 3 multiplied by x to the 5. You should have learned in previous grades the following. The order in which you multiply things together doesn't change the outcome. It doesn't change the answer. If I tell you to take 2 times 3 times 4, and you do this left to right, you get 2 times 3 is 6, and then 6 times 4 is 24. We get 24. If I change the order of these three numbers and say, let's take 3 times 4 times 2, going left to right, 3 times 4 is 12, and then we still have to multiply by the 2, you're getting 24. And that should make sense to you that when you multiply things together, the order in which the multiplication takes place doesn't change the outcome. And that means I could rewrite this as 4 times 3 multiplied by x to the 7 times x to the 5. And all I've done is I've grouped the coefficients together, because now I can say that 4 times 3 is 12, and I can take x to the 7 times x to the 5 and add the exponents and get x raised to the 12. In the previous lesson, while you were warming up your brain to these exponents, you might have had to have written for the variable part of this, you might have written x raised to the 7 plus 5. I don't think that's necessary. So what have we learned in this example? This is the answer. I'm not going to give you an example that we're going to work through together unless we learn something from it. What we have learned is that when you have exponential expressions, which of course contain a coefficient and a power, you were allowed to multiply the coefficients to get the coefficient of the answer, and you were allowed to multiply the powers to get the power of the answer. So we don't need to do anything written in between the answer and the question. We just look at it and we say 4 times 3 is 12. X to the 7 times x to the 5 is x to the 12. We can follow that lead here and recognize that the coefficient of the first exponential expression is -4. So we're going to multiply that coefficient of -4 times this coefficient of 5 and get the new coefficient. We can also see that we have a power of p to the 4 multiplied by a power of p to the 7. So we're good to go now. -4 times 5 is -20. And then p to the 4 times p to the 7 is p to the 11 because we add the exponents of 4 and 7. And I don't want to put undue pressure on anybody, but you should be able to, at this level, write out what that answer is without having to go to a calculator. I'm just going to be brutally honest with you here. If you have to go to a calculator a month from now to figure out that -4 times 5 is -20, you're going to have serious problems down the road. You shouldn't need to go to a calculator to add single-digit numbers together like 4 and 7, or to multiply single-digit numbers. Of course, by the way, a negative times a positive gives you a negative. So that's -20 p to the 11. Take a look at the next one. Well, we're going to do the same kind of thing, except instead of multiplying, we are dividing. So what we have is an exponential expression on the top that has a coefficient of 35, an exponential expression on the bottom that has a coefficient of 7. We have the power in the exponential expression on the top is j to the 15, and on the bottom is j to the 6. Well, what we're going to do is we're going to divide the powers to get a power in our answer, and we are going to divide the coefficients to get a coefficient in our answer. 35 divided by 7 is 5, and then j to the 15 over j to the 6 means we're going to have j to the 15 minus 6 because of the quotient law. 15 minus 6 is 9, so we get j to the 9. So the answer to C is 5j to the 9. Basically, what A, B, and C demonstrate to you is if you're dividing expressions, you can divide the coefficients and divide the powers. If you're multiplying expressions, you can multiply the coefficients and multiply the powers. So in all of these, I'll just indicate, because I've been doing so, this is the answer, and this entire thing is the answer. This entire thing is the answer. Once again, if you need to pause the video to write things down or to think about things, you have that ability. Let's move on. D, 45h to the 5 over 60h squared. So first of all, we can divide h to the 5 by h to the 2, getting h to the 3. And all I'm doing, and I'm not going to be highlighting stuff over and over and over again, but we are taking h to the 5, dividing by h to the 2, so we're taking the top exponent of 5 and subtracting the bottom exponent of 2. And now we have a problem because we have 45 over 60, and we can't divide 45 by 60 and get a whole number. But what we can do is just recognize that this entire 45 over 60, it's a 45 over 60, we can just think of it as one number, whatever 45 over 60 is. And 45 over 60 can be whittled down. I know you can enter 45 divided by 60 on your calculator and convert it to a fraction. But I look at 45 over 60, and I see that 45 is divisible by 5, goes in 9 times. 60 is divisible by 5, it goes in 12 times, and then I can reduce 9 over 12 down by dividing them both by 3 and getting 3 over 4. So I write the following. 3h cubed over 4. Or I can write 3/4 h cubed. And I really like writing it this way. I also like writing it this way. Unfortunately for everyone, if this is typed out, it becomes, in appearance, this. And I don't like that. Later on down the road, I'll talk more about why I don't like that. But the basic reason is I can't see by looking at that h cubed, is that on the top or the bottom? It may seem like a very picky thing, but when I look here, that h cubed is on the top. When I look here, that h cubed is on the top. If you write that 3/4 kind of centered around the h cubed, it's not clear. It's not wrong, it's just not as useful as writing it the other way. Regardless, our answer, let me finish my highlighting here just to be consistent. Our answer is this entire thing, however you decide to write it. Let's take a look at E. Well, we're going to multiply the coefficients. You're going to multiply -6 times 7 times -4, and I don't have a problem or an issue with you using a calculator to do so. What are we going to get? 28 times 6, 42 times 4 is 84. Don't mind me, I'm just thinking out loud. I believe it's going to be 168, but of course we can check it on a calculator. And even myself, if I were making a key for an exam for my students, I would still use a calculator to double check things. So -6 times 7 times -4 is 168. And it's positive because the negative times the negative is positive, so you get 168. By multiplying the coefficients, multiplying the powers, we have p to the 5 times p to the 3 times p to the 9. Well, you're multiplying common bases, so you add the exponents. 5 plus 3 is 8, plus the exponent of 9 gives me a new exponent of 17. Just double checking my math before we move on. 7 times 6 times 4 is definitely 168. And p to the 5 times p to the 3 times p to the 9, I'm adding the exponents again in my head, is p to the 17. All right, number 2. Well, very similar to the first set of questions that we were doing. This x to the 6 times y to the 4 times x to the 7 times y to the 8 can be rewritten as x to the 6 times x to the 7 times y to the 4 times y to the 8, because the order in which you multiply doesn't change the outcome, doesn't matter. So I'm just grouping the x's together and saying now I can add the exponents. And I'm grouping the y's together and I can add the exponents. This is our answer, x to the 13, y to the 12. I am perfectly aware that I hope everybody is capable of going right to the answer without rewriting everything. So this is the answer. I'm rewriting this in this fashion just to demonstrate to you what's going on. But it's not necessary. Over here, it's the same kind of thing. You know, this is r to the 12 over r to the 4 multiplied by s to the 9 over s cubed. Well, we subtract the exponents on r, we subtract the exponents on s, and we get that. This is the answer now. There's no reason for you to write this. It's just me explaining what's going on mathematically. C. Okay, well, let's not rewrite all this. Let's just recognize that we have a whole bunch of coefficients being multiplied together. The coefficients are -6 times 2 times 4. That's going to give us a coefficient. We also have some powers with a base p rather. So when we multiply those base p powers together, we're going to get a base p power. And we also have base q powers that are being multiplied together. And before we go on, we just have to make sure of something in this first part where it's -6p q to the 4. The exponent on p is 1. P to the 1 is equal to p. In the third part where we have 4 p to the 5q, that q is to the 1. This is child's play. It's like taking candy from a baby once you catch on to things. It shouldn't be some complicated thought process. You should just be looking at this and saying, I need to figure out what -6 times 2 times 4 is, and you're going to get -48, and you've got a calculator. If you need to double check that, feel free, but I'm confident that that's -48. We have p to the 1 times p to the 3 times p to the 5, so we are looking at adding the exponents on p to get a single p power. A single power with a base of p. And we add the exponent of 1 and 3 gives us 4, plus the other 5 gives us 9. And then, of course, what we're going to do is we're going to add the exponents together for the powers of base q. Q to the 4 times q to the 2 is q to the 6, times another q is q raised to the 7, raised to the exponent of 7. And before I go on, I'm just going to double check everything. -6 times 2 times 4 is -48. We should have p to the 9, and we do. When I add the exponents of q together, I get q to the 7. By the way, this is me double checking things. And as you get deeper into high school math, along this academic route that you've chosen to take, you are going to have to get used to checking your work frequently, because the problems may have 5 or 6 steps, and it would be a shame to get something wrong because you wrote the wrong number down in step 1. So it's okay to second guess yourself. Maybe that's not the best way to put it. It's okay to say to yourself, I'm going to check my work because I make mistakes. You cannot do math without making mistakes. That's a fact. Okay, over here we can take 10 over 4 and reduce it down to 5 over 2. I have h to the 7 over h cubed. I subtract the exponents and get h to the 4. And I have k to the 11 over k to the 7. I subtract the exponents and get k to the 4. I just want to double check that before I discuss something else with you. It looks okay. The thing I want to make sure that you understand is when you have, and I'm going to pick h to the 7 divided by h to the 3, and you subtract the exponents and get h to the 7 minus 3. When you apply that law, you write whatever you get on the top. And I feel strange bringing this up because many of you will be looking at your work here and going, well, where else would you write it? Well, later on, we're going to have situations that will make you second guess where you should write things. So I'm just pointing out that when you subtract the exponents to get a new exponent, that new exponent is the exponent on the power when it's written in the top. So I just want to double check again. 10 over 4 can be reduced to 5 over 2. Subtract the exponents on h, you get h to the 4. And subtract the exponents on k, you get k to the 4 as well. All right, 4x to the 6 cubed. Well, 4x to the 6 means 4 times x to the 6, and this is raised to the exponent of 3. We have a rule, and I'm just going to write it in the center of the screen here, that says when you have a product raised to an exponent, and I'm just going to choose weird letters. In your note package on day 1, we said x to the y, x times y to the n. Okay, so this, maybe what I will do is I will write that. This is what we had, I think it was to the n. This is called the power of a product rule, and it's x to the n, y to the n. Well, if it's a times b to the p, it's a to the p, b to the p. If it's 4 times x to the 6 raised to the 3, then it will be 4 raised to the 3 times x to the 6 raised to the 3. We have a product raised to an exponent. So we are applying this power of a product rule and saying the product of 4 times x to the 6, all raised to the 3, will be 4 to the 3 multiplied by x to the 6 to the 3. Well, 4 to the 3 means 4 times 4 times 4, which is 64. And x to the 6 to the 3 is x to the 18, because we have learned that x to an exponent raised to another exponent is x raised to the product of the exponents. So we're combining a couple of laws here. Basically, we raise the 4 to the 3 to get to 64, and we raise the x to the 6 to the 3 to get x to the 18. This is the answer. We can do the same thing here. We can write negative 3 raised to the 2, and notice I put that negative 3 in brackets. We can write c to the 4 in brackets raised to the 2, and we can write d to the 3 in brackets raised to the 2. Negative 3 quantity squared is positive 9. If you're going to use your calculator to figure out what negative 3 quantity squared is, well, I hope you don't have to, but if you had to, then you need to put brackets around the negative 3. C to the 4 raised to an exponent of 2 is c to the 8, because when we have a power of a power, we multiply the exponents. And d cubed squared is d to the 5, is d to the 6, because we are multiplying the exponents. 3 times 2. So it's 9c to the 8, d to the 6 is our answer. The same thing goes here, but I'm going to rewrite this, and this negative in front of a fraction always drives me nuts. You have some stuff here, you have some stuff here, and then there's a negative in front. That means that the top of the fraction is negative, or the bottom is negative, or the whole thing is negative. They're equivalent. You know, if I said negative 3/4, or negative 3 over 4, or 3 over negative 4, they are all equal to negative 0.75. It doesn't matter where you put the negative. But putting it out in front, like where it is here, has problems. Lots of problems, but one that is fairly obvious is sometimes if it's out there in front, you don't see it. So my advice to you would be to rewrite this as negative 3f over g cubed, quantity to the 5. I like putting the negative on the top of a fraction rather than the bottom or out in front. And now this means I can take negative 3 raised to the 5. I can take f, raise it to the 5, and I can take g to the 3, raise it to the 5. This is kind of combining a power of a product and a power of a quotient. Basically, that 5 as an exponent is applied to everything. So what do we get? You figure out what negative 3 to the 5 is. It's negative 243. And then we have f to the 5 over g to the 15 because we have to multiply those exponents. Incidentally, and I know I looked at some of your work already from the first lesson for a few of you, and it's fine. When you do this kind of work, you want to work from one line down to the next line. You don't want to just keep writing equals, equals, equals left to right. That's incorrect. So you get negative 243 f to the 5 g to the 15, and that's our answer. For A is tricky. Let's put some 1s in with those negatives. This is negative 1, and then we have in brackets negative 1r cubed, cubed. So all I've done is I've squeaked a 1 after each of those negative symbols. So what this is negative 1, this negative 1, times this expression, but this expression is equal to negative 1 to the 3 times r cubed to the 3. I have to, with a power of a product, apply that exponent to the first part and to the second part. Because xy to the m is x to the m, y to the m. So we have this first negative 1, which is just negative 1. We have negative 1 raised to the 3, which also happens to be negative 1. Negative 1 to the 3, quantity to the 3, means negative 1 times negative 1 times negative 1. These two negatives cancel and give us a positive 1. And then we're multiplying that by an additional negative 1 here. We get negative 1. And then we have r to the 9. Well, this negative 1 times negative 1 is just 1, r to the 9. Well, we don't need to write 1. R to the 9 is 1 times r to the 9. And this is our answer. Next one, I have to take, I'm just trying to decide how I want to approach this. I'll do it this way. I have to take 4h cubed and multiply by 5i. No, I'm going to change my mind here. Because I have this, let me just rewrite it. And it's all raised to the 3. We should ask ourselves if we can simplify what's in brackets. If I do, the 4 times the 5 on the top is 20, and I have h cubed, I to the 5, over 15 I squared, and this is raised to the 3. So all I've done there is just multiplied the 4 by the 5 to get 20, but I notice that 20 over 15 can be reduced to 4 over 3. I have an h cubed, and I also have an I cubed. The reason I have I cubed is in the original expression, I have I to the 5 over I squared. I to the 5 over I squared. I to the 5 over I squared. So if I subtract those exponents, then I'm going to get I cubed. Now this whole thing is cubed, so what I can do in my next step is take the 4 and raise it to the 3. Take the h cubed and raise it to the 3. Take the I cubed and raise it to the 3. Take the 3 in the denominator and raise it to the 3. I don't know that you need to write this step that I just wrote, because you just, looking here, this is your eyeball. Looking there, many of you can say 4 cubed is 64. H cubed cubed is h to the 9. I cubed cubed is I to the 9. And 3 cubed is 27. Before I move on, I just want to double check everything. The lesson to be learned here, by the way, and I almost got sucked into missing it, is simplify what's in brackets first. So I just want to double check things here. It's fine. A couple more. I'm just going to simplify this by writing 24, x to the 9, y to the 12, and ask you to think about, by looking here and looking here, think about what it is I just did, and pause the video if you need to think about it a little longer. If you're back, what I've done is I've said that it's x cubed cubed, which is a power of a power, so I take the 3 times the 3, and when I do that with the y to the 4 to the 3, 4 times 3 is 12. I also have on the bottom 8. The 8 comes about because on the bottom I have 2 and it is cubed. 2 cubed. Two cubed is 8 because it's 2 times 2 times 2. What else do we have on the bottom? We have x squared to the 3, which is x to the 6. And now I can focus my attention on the fact that I have some x's here, some x's here. I also have coefficients here and here. I can divide the coefficients. 24 over 8 is 3. I can divide x to the 9 by x to the 6 and get x cubed by subtracting the exponents 9 minus 6. And the leftover part, which doesn't have anything to cancel with, is y to the 12. I just want to double check my work here. And it is fine. This is the answer. Let's take a look at this one, which I think might be the last question. This will be 4 to the 3. I'll show all of the steps this time. Times a cubed to the 3 times b to the 8 to the 3 times 5 times a times b squared. Essentially, again, to review this exponent of 3 gets applied to everything inside of the brackets. So it's 4 to the 3, that's 64. It's a cubed to the 3, which is a to the 9 when we multiply these exponents. And it's b to the 24. We also have a 5, an a, and a b squared. Look, we just keep going until we can't go any further. I can now take the 64 times the 5 and get what I believe is 320. I can take the a to the 9 times a to the 1, which is a to the 10. And I can take the b to the 24 times b squared and get b to the 26. And I'm just going to check my work here. 4 cubed is 64 times 5 is 20, carrier 2, 320 is correct. I'm going to have a to the 9 times a, which is a to the 10. I'm just speaking out loud. I'm talking to myself here. You should be kind of doing the same thing when you check. Well, maybe not talking to yourself, but reasoning it out. B to the 24 times b squared is b to the 26, so this is the correct answer. Once again, we didn't learn any new math today. What we learned is that you can take all of these exponent laws and apply them to more complicated situations. Oh, a couple more quick ones I just want to see. Yeah, why not? It won't take that long. This is negative 1 p to the 7 over negative 1 p in brackets to the 5. So on the top we have a coefficient of negative 1 and then p to the 7. On the bottom we have negative 1 to the 5 and p to the 5. So we get negative 1 p to the 7 over negative 1 to the 5. This part of the bottom is still going to be negative 1 because it's negative 1 times itself 5 times, which is an odd number of negatives, which will retain its negativeness. And then we have p to the 5. The negative 1 divided by negative 1 is 1, so we don't need to write anything. P to the 7 over p to the 5 is p squared by subtracting the exponents. Negative 2 raised to the 3 times c squared cubed times d cubed cubed times 4a to the 5 b to the 7. What's it going to give us? Well, this is negative 8 times the 4 over here is negative 32. Then we have an a to the 5. We have a b to the 7. We have a c to the 6 by multiplying exponents. And we have a d to the 9. I want to double check these last two that we're looking at here. Negative 2 cubed is negative 8 times 4. That's correct. A to the 5, b to the 7, c to the 6, d to the 9. Correct. This is the answer. And this is the answer. One final one. (72) x to the 5, y to the 11. I need to take that negative 1 z cubed and raise it to the 4, which means negative 1 to the 4 and z cubed to the 4. You know, if I were in front of you, a class right now, I would say, how many of you would have just written z to the 12? And I suspect that many of you that are watching would have. On the bottom, I have 8. I have 2 cubed, x squared cubed, and y cubed, and another y cubed, and a z to the 8. So just, pause your thought process here and take a look at everything and make sure you know how I'm getting each of those almost dozen items and writing them down. I'm applying that exponent of 4 on the top to the negative 1 and the z cubed. I'm applying the exponent of 3 on the bottom to the 2, the x squared, and the y, and everything else is just written there. So what do we get? 72, x to the 5, y to the 11. This is positive 1, so I don't need to write it. Z to the 12. On the bottom, we have 8 multiplied by this. We already talked about this. 2 to the 3 is 8. So 8 times 8 is 64. I have x to the 6. I have y to the 3 times y to the 3, which is y to the 6. And then I have z to the 8. We have to figure out what 72 over 64 is. And there comes a time in our lives where, particularly at the end of a lesson, maybe we just want to use our calculator. It's okay to take the easy road sometimes. So I'm going to use my calculator to figure out what 72 over 64 is. 72 divided by 64 is this in decimal form. And if you hit the math key and go enter, enter, you get 9/8. So we're going to have a 9 on the top and an 8 on the bottom. I'm going to deal with the z's first. Z to the 12 over z to the 8. We take 12 minus 8 and get z to the 4. Y to the 11 over y to the 6. We subtract the exponents and get y to the 5. X to the 5 divided by x to the 6. We subtract the exponents of 5 minus 6. Top exponent minus bottom exponent. And that gives us x to the negative 1. And we write it on the top, as I said a little while ago. And I've purposefully put this problem in here because this is going to be what our answer is today, but tomorrow we're going to learn what a negative exponent means, and we will take a look at a different way to get this answer. So let me double check all of my work here. 9 is correct, 8 is correct, x to the negative 1 is correct, y to the 5 is correct, and z to the 4 is correct. So this is our answer. Same thing as the previous lesson. There's a whole boatload of problems in your handout on pages 12 to 14. My recommendation would be that you are working on these problems today, in whatever time you have left that you're going to dedicate to math today in school, or at home if you're learning from home, and spend the same amount of time that would be a full class, so another hour at least, working on more of those problems before you move on to lesson 3. So I hope you found that helpful. I've talked to a couple of you about this method of learning, and so far the response is fairly positive. You like it because you can access it whether you're at home or in the building. So I'm really glad that it's helping you out and making your life a little bit easier. Hope to see you in the building soon. If not, take care until I do. Talk to you later.